Hey everyone, it's Hawk here. Today we're going to be doing statics, which is chapter 13F on your textbook. More specifically, we're going to go through question 15, which is a really interesting one because it's not like your normal typical static question. It's got lengths in it, so 5 centimeters, 12 centimeters, you got unit lengths, which is a bit weird because normally you're given forces, not lengths. So we'll see how that works. Right, a particle of mass 5 kilograms, so immediately we know the mass, is suspended by two strings of length 5 centimeters and 12 centimeters respectively, attached at 2 points at the same horizontal level and 13 centimeters apart. So basically whenever you're doing these kind of force questions, you always want to draw the diagram. So you have a horizontal level, you can call that ceiling, think of it either way, and you have an object attached to two strings. So you got the short string, 5 centimeters, and then you also have the long string, which is 12 centimeters. Right, and there's that object there, just attached with two strings. Okay, obviously, this is in terms of centimeters. This is 13 centimeters apart. And if you want to draw forces, this string right here will have that force, and the long string would have this force. So pulling it up towards the horizontal, towards the ceiling. But there's also another force, and obviously when you're doing static, guys, most of the time you'll have three forces and not just two, and that other force is your weight force. So that is weight equals to mass times gravity, which is 5g. Okay, first of all, you're not given forces, and you're also not given any angles, which is a bit different. So how do you find angles? So if you want to find the tension in the shorter string, how do you find this tension? It's not 5. 5 is the unit length. So remember, our goal is to find tension on the short string. So how do you do that? First of all, step number 1 is you need the angles surrounding the object, right? So if you need the angles, but we don't have any, how do you find that? Here's a trick to this question. You see 5 centimeters, 12 centimeters, and 13 centimeters. They didn't give you those lengths for no apparent reason. It's because there's actually a relationship between 5, 12, and 13. If you square 5, you add it with 12 square, you actually get 13 square, which is your Pythagoras. So that means a square plus b square equals c square. Therefore, this angle right here is 90 degrees. So this triangle between 5, 12, and 13 is a right angle triangle. Okay, so once you know it's a right angle triangle, that means you can use your SOHCAHTOA, so sine, cos, and tan, to find these angles, to which you can find the other angles surrounding the object, which is what you need to solve this question. So if you want to find this angle, let's call it theta 1 right here. Theta 1, so sine of theta 1 equals to 12 opposite divided by hypotenuse, which is 13. So therefore theta 1 equals to, chuck inside your calculator, you should get 67.38 degrees. And of course, if you want to find theta 2, it's the same thing. Sine theta 2 equals to 5 instead, divided by 13. Chuck inside your calculator, you should get 22.62 degrees. So if you add these two angles up and the 90 together as well, you should get 180, which makes your triangle. Okay, so after you find this angle, when you allocate it to these other angles right here, so this angle and that angle, how do you do that? Well, it's actually just quite simple. You draw a straight line, horizontal line, and we know through alternative angle, this is 67. So I'll call that theta 1, 67 right here. So therefore, alternative angle, this one right here, is also 67 because alternative angle. So if this is 67, we know this is 90 right here. This is 90. 67 plus 90 would give you 157.38 degrees. So 157.38 degrees, that's this entire angle right here. And of course, if you want to find this other angle, you can either just go 360 minus 90 minus 157.38, or use the same rule, alternative angle, find this angle, which is alternative to that, and just add it with 90 degrees, which is your, because this is horizontal and that's vertically down. So 90 plus 22 should give you an angle of 112.62 degrees. Okay. Once you have all your angles, it's actually not that hard from that point. It's just as the same thing as all your other statics question. But over here I'll show you I guess what I usually do with triangular forces. You can of course use Lami's theorem, which is a super shortcut. You should always be using it to save a lot of time, but I'll just go through the long way just in case, you know, it's good to know those as well. So 5 centimeters, we draw from our object. This is your 5 centimeter force. Don't know what that is, call it T1. What I want everyone to do is extend the line, extend this vector, but just have it a dotted lines. It only ends until here, but just extend it. We'll need those later on to get your angles. Okay, then draw the 12 centimeters one, not from the dots, from the where the object starts, from the arrow where it ended. So that's your T2, the 12 centimeter string, and extend the line again. Afterwards, draw your weight force right here, going down, meeting back where it started. We know the force for this one, the weight force, 5G, but extend it again. Okay, so why do we extend? That's because it is to help us find the angle. So if you have a look over here, the angle between the green and the red, so the green, the 5 centimeters force, and the red one is 90 degrees. So this angle would be 90 degrees right there. And if this external angle is 90, the interior would be also 90. So supplementary angles, 180 minus 90 equals 90. So you know this angle is 90, right? And of course, to find this interior angle, you can just find this exterior angle. And what is that equals to? Well, we have a look at our diagram. What angle is between the red force, the long one, and the weight force? The red force, the weight force, that is 112.62. So 112.62. Supplementary angle says, okay, 180 minus 112.62 should give me my 67.38. And yeah, you don't have to find the last one. You just go 180 minus 90 minus that. Or if you want, you can also do the same thing. Between the green and the weight force, green weight force, that's 157. Right there, 157.38. So therefore 180 minus that should give you 22.62 degrees. Once you have all your angles and your forces and your diagram, you can easily find whatever force you need. So in this question, we need to find the short length, which is T1. So we use sine rule, which is T1 divided by sine of the angle opposite of it, which in this case is 67.38 degrees, equals to, we know the force, which is 5G. We use the one that we know, so in this case 5G divided by sine of the angle opposite of 5G, which in this case just happens to be 90 degrees. Of course, you can also use your trig, because it's a 90 degrees. To find T1, you can use sine, cos, or tan as well, that works. But because sine rule, we're so used to it, you might as well use it, right? It's not that hard. I mean, sine 90 is just 1. So just flip this over, bring sine 67.38 degrees up top, and you'll be able to solve for what T1 is. And if you do that, guys, you should get, on the calculator, 45.23 Newton. So that's it. They only ask you to find for the tension on the shorter strings. You don't have to find the long string. There's no point. You're wasting time. So in this case, yeah, that's all you need to do. Get all your angles surrounding that. That's step number 1, surrounding the object. Step number 2, draw your diagram. And of course, extend these lines so that it's easy for you to see where the angles are, and just fill in the exterior and then interior. And step number 3 is use sine rule, and that's pretty much it. So if you have any questions, guys, just leave a comment and I'll see you next week. Thanks for watching.